Hi, in this second part of the video lecture, I will be showing you how to assess the assumptions in multiple regression analysis. Basically, in multiple regression analysis, we have 7 assumptions. Number 1 is normality. Number 2 is normality of the error term. Number 3 is linearity. Number 4 is multicollinearity. Number 5 is constant variance. And number 6 is outliers. Number 7 is autocorrelation. So these are the 7 assumptions we need to test. Okay, in the first part of the lecture, I showed you some text boxes that you need to tick when you do multiple regression. Okay, now we will assess the output. So when you run your multiple regression, you will get this table called histogram. Okay, one of the text boxes we tick in the previous slide was normality. So in this normality, we will have a superimposed histogram with a normal distribution. Okay, if you see, this is your normal distribution, and we can also look at the mean values and standard deviation. Okay, for a standard normal distribution, the mean value will be 0. Standard deviation should be close to 1. Okay, here the mean value given here is 1.53. E to the power of negative 15. What it means is you have to take 1.53 divided by 10 to the power of 15. Okay, 1.53 divided by 10 to the power of 15, which will be actually 0.00000. Okay, so it is actually 0. And standard deviation, if we round it up, we get a 1. So we can assume that the data is actually normally distributed. Okay. Number 2 will be normality of the error term. You need to check that the residuals are approximately normally distributed. This we will look at the normal PP plot. Okay, this is the normal PP plot given. What we want to see is these points here, they are very close to the line. If you have a cyclical pattern increasing and decreasing, then you have residuals which are not normally distributed. So this is how you assess assumption number 2, which is normality of the error term. The third assumption is linearity. There needs to be linear relationship between the dependent variable and each of your independent variables. Okay, so that is what we call as linearity. How do you assess them? We will have different kinds of relationship that we can assess. Linear relationship, curvilinear relationship, and no relationship. Okay, curvilinear relationship is when you have the points are moving this way, curvy, okay, or this way and this way. This is curvilinear. No relationship means there's no pattern. The points are going everywhere, or the points are like this. So there's no increasing or decreasing pattern. The one we are looking for is like this, where we can draw a straight line in between the points. So this is what we call as positive relationship because the numbers are increasing. This is negative relationship. So here when the x increases, y also increases. Here when the x increases, here when the x decreases, okay, y increases. Okay, so that's why the negative relationship. Okay, so here we will get, since we have two independent variables, the first one is your price and the second one is your advertising. Okay, so for price the relationship is actually negative. The line is going down here. Okay, and for advertisement the relationship is positive. Okay, the line is going up. Okay, that's how you assess linearity in multiple regression. Assumption number 4 is what we call as constant variance. Okay, constant variance. Okay, what we want to see is when we draw the plot here, okay, the variance, if the variance from smaller number becomes bigger, okay, and here also bigger, fan like this, okay, from small to big, or from big to small, they are not constant. They actually from small number, the variance is actually increasing. Okay, what we want to see is like this. We have some no pattern at all here. So the variance remains, the variance remains the same from 0 to whatever number of x's. So in your SPSS result, you get a regression studentized residual and a regression standardized predicted value. Okay, and you can draw a line here, 0 here, and some are above, some are below. There's no pattern of increasing or decreasing order. So we can safely conclude we have constant variance. So assumption number 5 is what we call as multicollinearity. Multicollinearity measures whether your independent variables are highly correlated. If your independent variables are highly correlated, you have a problem called multicollinearity. Okay, so the values that you need to check against is we will get output called variance inflation factor. This must be less than equals to 5, and the conditional index less than equals to 30. Okay, so the cutoff values for VIF is different in the literature, but you can use the 5. You can use the 5. How do you check collinearity is when you run your regression, you get this VIF. Okay, VIF. Okay, this VIF is less than 5, right? Both the VIF is less than 5. And then the next one is the conditional index, which is here, is only 19. And you don't have any values. Any two values are above 0.9. So with these two things, we can conclude that we don't have a problem called multicollinearity. Multicollinearity. Okay, number 6 is what we call as outliers. What we mean by outliers is some of the points which are very far away from the regression line. Okay, the regression line. So this is how it looks like. The rest of the points are very close to the line here, but we have one point here which is very far away from this regression line. Here we have a negative relationship, here for positive relationship, here negative relationship. Most of them are near the line, but we have one here which is very far from the line. These are what we call as outliers. Okay, so when you run your regression analysis, you may get a table like this, and they will give you a case-wise diagnostic. Okay, this 45 and 56 is the case number, row number 45 and row number 56. They are actually case number 45 and 56. They are considered outliers because the studentized residual is 4.105 and 3.3. Okay, normally for outliers, the values must be within plus minus 3, plus minus 3. Okay, anything greater than 3 or anything less than 3, they are considered outliers. Assumption number 7 is autocorrelation. Autocorrelation. You should also have independence of observation, independence of residuals. This is normally checked with the value called Durbin-Watson. Okay, Durbin-Watson value ranges from 0 to 4. Values of 2 are the best, but the numbers normally range from 0 to 4. So in the last lecture also you look at how do you decide on the cutoff value for Durbin-Watson. So as long as your Durbin-Watson values are 1.5 to 2.5, you can safely conclude that you don't have a problem called autocorrelation. Okay, autocorrelation. Okay. When you run your SPSS results, if you have clicked the box called Durbin-Watson, they will give you this number here, 1.683, which is already between 1.5 and 2.5. So we can safely conclude we don't have a problem called autocorrelation. Okay, autocorrelation. The next thing we need to do after we check the assumption is we wanted to test individual variables. In this model, we have two independent variables, which is price and advertisement. Okay, price and advertisement. So we want to use a test called t-test to test this relationship. So the hypothesis that you will write is H now beta 1 is equals to 0. H alternative is beta 1 not equals to 0 if you don't have a direction. Okay, if your relationship is supposed to be positive, your alternative you have to write beta 1 greater than 0 if it's positive. If it's negative, you will write beta 1. You will write beta 1 is less than 0. Okay. Again, if you have no direction, if you just want to test a two-tail hypothesis, whether they are significantly related, okay, we will write beta 1 not equals to 0. If your hypothesis is x and y is positively related, then this will be beta 1 greater than 0. If you write the hypothesis beta 1 will be negatively related to your dependent variable, then the beta 1 will be less than 0. So that is how you decide whether you have a non-directional hypothesis or a directional hypothesis. Okay. So to test these individual variables, these are the hypotheses we have already decided. The test statistic will be t stats, beta I or beta j minus 0, standard error of the beta, okay, divided by standard error of the data. And the degrees of freedom is n minus k minus 1, n minus k minus 1, okay. So if you want to look at the table for t, we will look at the degrees of freedom 15 minus 2 minus 1, okay. And then you can look at the 5% column to see what is the cut-off value, okay, cut-off value. So how do you interpret the result from the SPSS output? They will give you a table like this, and we will have a t value here and the p value here, okay. Okay, the t value here, negative 2.306, you will compare with the table value. 2.88855, you will also compare with the table value, okay. So here we have what we call as the p values, okay. The p values given in SPSS is actually two-tail p values, two-tail p values. So if your hypothesis is negative or positive, which is one tail, then you have to take this p value, you divide by half, divide by 2. So you divide by 2. So this is actually significant. This is also significant. Okay. So this is how you can infer about the slope using the t-test. So if we write a beta equals to 0 and beta not equals to 0, degrees of freedom is 12. The cutoff value from the table is 2.1788. 2.1788. So the cutoff value is 2.1788 negative and 2.1788 positive. And then we will do the calculation using the t values. So the results already given, 2.306 and 2.855. So negative 2.306 is actually here, and positive 2.855 is actually here. So both are in the rejection region. So your conclusion will be reject H null for both variables. Okay, there is evidence that both price and advertising affect pie sales at 5% level. Okay, that's how you conclude. Okay, that's how you conclude. Okay, if you are supposed to write the confidence interval estimate for the slope, this is how the formula works. Beta j means the beta for independent variable j plus minus t alpha divided by 2, which we already calculated just now, 2.1788 times the standard error of the particular independent variable. Okay, degrees of freedom is n minus k minus 1. So when you write the confidence interval for effect of changes in price on pie sales price, so we take the beta value negative 24.975 plus minus, this is your t value, 2.1788 times your standard error of price, okay, which is 10.832. So the interval estimate will be negative 48.576 and negative 1.374. Okay, those are what we call as confidence interval estimate for price. So we can also calculate the same for advertising. Okay, advertising. So how do you report the results for multiple regression? This is how you can write. A multiple regression was run to predict pie sales from price and advertisement. These variables significantly predicted pie sales. F is 2 and 12, k and n minus k minus 1 equals to 6.537. This is your f value. P value is less than 0.05 and the r square is 0.521. Both variables were significant predictors of pi sales. So you can also write this is the overall model. And the second part here, we are looking at individual variable. So price, beta value negative 461, T 12 degrees of freedom equals to negative 2.306. P less than 0.05 was negatively related to pi sales, while advertisement beta equals to 0.570, T 12 degrees of freedom 2.885, P less than 0.01 was positively related to price. Thus, H1 and H2 of this study was supported. Okay, so we have only two independent variables. H1 is your price. H2 is your advertisement. It's your advertisement. Okay, so that's how you are expected to report. Okay, the multiple regression results. So far, we have looked at independent variables which are continuous. Independent variables which are continuous. Okay, if you have independent variables which are categorical, for example, yes or no, on or off, male or female. Okay. Normally we collect data for male and female as 1 and 2. So what we need to do is you have to recode them into 0 and 1. Okay, 0 and 1. Okay. So if you have more than 2 levels of the categories, then you have to take number of category minus 1. Okay, number of category minus 1. So what we will do before we run the regression is, when we run the regression, we have a y estimated equals to beta 0 plus beta 1 x1 plus beta 2 x2. Okay, so that here we have pi sales as your dependent variable, price as your independent variable number 1, and holiday as independent variable number 2. So what we have decided is 1 is if a holiday occurred during the week, and 0 if there was no holiday that week. Okay, so we have 1 and 0. So when we run the equation, when the holiday occurs in the week, your equation is y beta 0 plus beta 1 x1 plus beta 2 times your holiday. But if there's no holiday, this beta 2 times 0 is not there, right? So that's why the equation becomes only this plus this. Okay, this plus this. When holiday happens, we have 1, 2, and 3. Okay, so your group 0 will be what we call as the benchmark group here, 0. We want to see whether this group, when there is holiday in that particular week, is the beta value is higher than or lower than. So the line will be lower than or higher than. If you get a positive beta values, it denotes that the slope is higher than the 0 group. If you get a beta which is negative, it denotes the slope is lower than the benchmark group. So once we run the analysis, when we get an equation like this, sales equals to 548.1 minus 26.1 times price plus 90.1 times holiday. Okay, so the sales number of pies sold per week is a function of this and this. So if there is holiday, which is 1, then the whole equation works. If there's no holiday, this part here is actually 0. Okay, this part here is actually 0. 90.1 times 0 is 0. So you only have this part. Okay, so the conclusion here is B2 90.1 on average. Sales were 90.1 pies greater in weeks with a holiday compared to the weeks without the holiday. Okay, so higher than, how much higher than? Okay, that's how dummy variables are interpreted in multiple regression. Okay, for the chapter summary, in this chapter, what we have discussed so far is how to develop a multiple regression model. how to interpret the regression coefficients, how to determine which independent variables to include in the regression model, how to determine which independent variables are most important in predicting a dependent variable, and how to use categorical independent variables in a regression model. Plus, we have also looked at how we can assess all the assumptions that we need to test in multiple regression analysis. Okay, so those are some of the things which will be useful also in your project. Okay, thank you very much.